Good morning everyone. Today we will discuss about fitting a exponential curve. Here mainly we are having two types of exponential curves. The first one is y equal to a e power bx and the second one is y equal to a b power x. These two are two types of exponential curves. So now we are fitting these two exponential curves now. So for this type of equation, so first I am doing the first one. So if you are having exponential, we are taking logarithm on both sides, for left hand side and right hand side. See here, y is the dependent variable, x is the independent variable. So here we are taking log base e on both sides. Okay, so we get log y base e equal to log a e power bx into base e. Since we know that log ab can be written as log a plus log b. Since we know that log ab can be written as log a plus log b. So now we are substituting log y base e is equal to log a base e plus log e power bx base e. Again, since we know that log a power n can be written as n into log a. Since here e power bx we are having, so that can be written as log y base e equal to log a base e plus bx into log e base e. Again we know that log e base e's value is equal to 1. Since we know that log e base e is equal to 1. So now we are substituting here log y base e equal to log a base e plus bx. Right. Now you are representing log y base e. Log y base e is equal to capital V. Let it be, and log a base e can be represented by capital A. So now we are substituting here, we get the equation is V equal to A plus Bx. V is equal to A plus B. So let it be, this is equation 1. So now equation 1 in terms of straight line equation. So for solving this straight line, we are fitting the given data, that means we have to write down the normal equation. So for straight line equation, normal equations are we are writing using the method of least squares method. So that is, we know that summation Vi is equal to Na plus B summation Xi, let it be, this is equation 2. And for the second normal equation, this can be written as summation Vi into Xi equal to A into summation Xi plus B into summation Xi square, let it be, this is equation 3. We are solving these two equations, that is solving equation 2 and equation 3, we get two unknown values, capital A and small b. We get capital A and small b. But in our exponential curve we have in terms of small a and small b. So here our wish is we have to find out this small a and small b. Since here small b we are getting, for getting small a, since we know that small capital A is equal to log a base e. This implies small a can be written as anti-log of capital A. This is also can be written as e to the power of capital A we are doing, we get small a. So this small a we are substituting in given equation, that is y equal to a e power bx, we are getting the exponential curve for the given data. And the next exponential curve we are having sometimes y equal to ab power x term. So we are having y equal to ab power x means we cannot find out directly. So for this type of equations we are taking logarithm on both sides. So let it be, this is equation 1, taking log base e to equation 1. We get log y base c equal to log ab power x into base c. Okay. So again this can be written as log y base c equal to log ab can be written as again log ab can be written as log a plus log b. Same thing we are applying here, log a plus log b power x base c. Next, log y base c equal to log a base c plus again b power x we are having. We know that log a power n can be written as n into log a. So this power can be written as x into log b base e. Okay. So now all the terms in terms of a logarithm. So let it be, I am taking, let log y base c can be taken as capital V and log a base c can be taken as capital A and log b base c can be taken as capital B. Okay. These terms we are taking into like this. Now we are substituting here, we get capital V is equal to capital A plus capital B into small x. Let it be, this is equation 2. Now equation 2 in terms of a straight line equation. So we know that how to fit a straight line by using method of least squares method. So using that method of least square method, now we want to write down the normal equation. So the two normal equations are summation Vi into equal to Na plus B into summation Xi. Let it be, this is equation 3. Next, for the second normal equation, we are multiplied by summation xi. So summation xi into Vi equal to A summation xi plus B summation xi square. Let it be, this is equation 4. So now you are solving equation 3 and 4. So we are getting two unknown values. The two unknowns are capital A and capital B. Solving equation 3 and 4, we get capital A and capital B. But in equation 1, we want small a and small b value. So now we are interchanging capital A, capital B into small a, small b. So using this substitution, since we know that capital A is equal to log small a base c, this implies small a equal to anti-log of capital A. This is also can be written as e to the power of capital A. Same as it is b also we are writing. So b is equal to log b base c. So this implies b can be written as anti-log of capital B. This is also can be written as e to the power of capital B. Right? So using these two values, so these two values we are substituting in equation 1, fitting a power curve y equal to ab power x for the given data. Fit a curve y equal to a e power bx for the following data and find x equal to 4.5, and the data is x and y 1, 2, 3, 4, 5, 6 and the corresponding y values are they are given. Okay. So first of all, for the given data we have to write down the normal equations by using least squares method. So given y equal to a e power bx, let it be equation 1. So now we want to write down normal equations for this one. For writing normal equation, this can be take both sides logarithm, already we done. So taking logarithm on both sides, we get log y base e equal to log a base e plus bx we are getting. Okay, already we done this part. Again, this can be represented by capital V equal to capital A plus bx. Let it be, this is equation 2. Since we know that capital V equal to log y base e, capital A is equal to log A base E. So now we want to write down the normal equations for this equation 2. Equation 2 in terms of straight line equation we are having. For straight line equation, the normal equation is summation Vi equal to Na plus B summation Xi. Let it be equation 3. And summation Xi into Vi equal to A summation Xi plus B into summation Xi square. Let it be, this is equation 4. So now these two are the two normal equations. Now using the given data, we have to find out summation Vi, summation Xi, summation Xi square, summation Xi and Vi value. So for this, we are constructing the table taking X values and Y values. X values are, they are given 1, 2, 3, 4, 5 and 6. And Y values are, they are given 1.6, 4.5, 13.8, 40.2, 125, 300. Okay. So next we are finding Y means we are taking here we want summation Vy. But V means log Y base E. That means we are taking logarithm for this Y values. So V is equal to log Y base E. In your calculator, base E means we are using ln button. Okay, for finding log base E means we are using ln. If you are having log base 10, we are using log button, right? So now we are finding log base E Y values, that means these values. So ln first value is 1.6, that is equal to 0.4700. Next value, now ln 4.5 is equal to 1.5040. Next, ln 13.8 is equal to 2.6246. Next, ln 40.2 is equal to 3.6938. Next, ln 125 is equal to 4.8283. Next, ln 300 is equal to 5.7037. So these are Vi. So for finding summation Vi, we are finding V values. Next we want summation Xi into Vi. So that means we are multiplying X into V. Okay. So this one into this one. 1 into 0.4700 is 0.4700. Next step. 2 into 1.5040. We get 3.008. Next 2.6246 into 3. We get 7.8738. Next 3.6938 into 4, that value 14.7752. Next 4.8283 into 5. So that value is equal to 24.1415. Next 5.7037 into 6. So that value 34.222. You are multiplying X values into V values. We get X into V. So now we want the summation of Xi, summation of Xi square also. So here I am finding X square, that means X value square. 1 square is 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, 6 square is 36. So now we want a summation of all these values. That means we are adding all the values, right? So I am adding equal to 21. So we no need to find out summation Y because there is no summation Y. So next I am finding summation Vi values. We are summing all these values, we get 18.8244. 18.8244. Next, X into V. that means you are summing all these values. Summation xi into vi is equal to 84.4907. Next, you are taking summation xi square. That means you are adding all the values in x square. 1 plus 4 plus 9 plus 16 plus 25 plus 36 is equal to 91. Okay. So, now we get all the values. We are substituting in equation 3 and equation 4. Equation 3 implies summation vi is 18.8244 equal to n means number of observations. We are having 6 observations, 6a plus summation x is 21b is, let it be equation 5. Next, for the second one, second equation, summation xi into yi, that is equation 4 implies 84.4907 equal to a summation xi. Summation xi is 21a plus summation xi square is 91b. Let it be, this is equation C. So, now we are solving these two equations. We get capital A and small b value. For solving these two equations, two unknowns means directly using the calculator we are finding. For this, our calculator mode we are changing into equation mode. For this, so press mode 3 times, we get equation 1. So, press 1. Two unknowns we are having, so press 2. Give the values of a1, b1, c1. a1 means a quotient, b1 means b quotient, c1 means constant. This value c1. So, that is 6 equal to 21 equal to 18.8244 equal to b1. So, a2, a quotient 21 equal to 91 equal to 84.4907. Press equal to, we get capital A is equal to minus 0.58366. Next, press equal to, we get small b value 1.06316. Okay, but for equation 1 we want small a and small b. Already we get small b, now we want to find out small a. Since we know that capital A equal to log a base c, this implies small a equal to anti-log of capital A, or this is equal to e power capital A. I am taking e power capital A, this implies small a equal to e shift ln, we are getting e power. So, that value minus 0.58366, we get that value is 0.5578. So, now we get small a and small b. This small a, small b values are we are substituting in equation 1. Substitute a, b values in equation 1. So, we get, now substituting small a, small b values in equation 1, we get capital Y is equal to, a value is 0.5578 into e power bx, b is 1.06316 into x. So, which is known as our exponential curve. We are finding two constant values. But in our question they are asking find x equal to 4.5 value also. That means substitute x equal to 4.5 in above equation, we get y is equal to 0.5578 e power 1.06316 into 4.5. So, we are simplifying this value using calculator. We get y at 4.5 value. This value is equal to y equal to 66.7173. So, this is the y value at x is equal to 4.5. So this is related to exponential curve fitting a given data. Next problem. Find the curve of the best fit of the type y equal to a e power bx to the following data by the method of least squares, and they are giving x and y value. So here we want to fit a data for y equal to a e power bx. Y equal to a e power bx means again which is known as a exponential curve. So let it be, we are taking given y equal to a e to the power of bx, let it be, this is equation 1, right? So for fitting this curve, we are using the least squares method, we are fitting. So before going to the least squares method, first of all this equation we are changing into straight line equation. For this, taking logarithm on both sides, already we done this part in the previous session. So now taking logarithm, we get log y base e is equal to log a base e plus bx we are getting. So again this log y base e can be written as capital V is equal to capital A plus bx, where log capital V is equal to log y base e and capital A is equal to log small a base e. So now this equation can be written as like this, V equal to A plus Bx. So now V equal to A plus Bx is known as a straight line equation. Now we are using the method of least squares method. We are writing the normal equation for this equation 2. So that is summation Vi equal to Na plus B summation Xi. Let it be, this is equation 3, and second normal equation is summation xi into Vi equal to A summation xi plus B summation xi square. Let it be, this is equation 4. So now we want to solve this equation 3 and 4. We are getting capital A and small b value. So before going to that, we have to find out, for finding this a and b values, we have to find out summation Vi, summation xi, summation xi square, summation xi and Vi values. So for this we are constructing a table. So in table I am taking x values and y values. X values are there given 1, 5, 7, 9 and 12, and y values are there given 10, 15, 12, 15, 21. Next, so here we want summation V. So V means log y. So we are taking log base e to the y values, we get a V values. V is equal to log y base e. So base e means in your calculator we are using ln value. So now ln 10, that value is equal to 2.3025. Next step, ln 15, that is 2.7080. ln 12, that is 2.4849. Next, ln 15, that is 2.7080. ln 21, that equal to 3.0445. These are a V values. So next we are finding x into V. That means we are multiplying x into y, we are getting this one. So that is 1 into this one, 2.3025. 5 into 2.7080, we get 13.54. Next, 7 into 2.4849, that equal to 17.3943. Next, 9 into 2.7080, that value is equal to 24.372. Next, 12 into 3.0445, that value 36.534. So now we are taking summation of all these values. So this is for summation xi, that means adding all the values in x. So that is 34. Here next we want summation vi. So we don't want summation y. So we are not finding that one. Next summation vi, that is equal to, adding all these values, we get 13.2479. 13.2479. Next we are adding all these values. We get summation xi into vi is equal to 94.1428. So now we get all the summation values. So these summation values are, we are substituting in equation 3 and equation 4. So this equation 3 implies NA plus, where N is number of observation. They are giving 1, 2, 3, 4, 5. So that can be written as 5A plus summation xi into B. So 34B is equal to summation Vi. So that is 13.2479. Let it be. This is equation 5. Next, second equation, if you are substituting, in equation 4 we are substituting. Equation 4 implies A summation xi, 34A plus B summation xi square. So here we want to find out x square also. So that is, we are taking the squares of x values. So 1 square is 1, 5 square is 25, 7 square is 49, 9 square is 81, 12 square is 144. We are taking summation all these values, that means you are adding all these values. 1 plus 25 plus 49 plus 81 plus 144, we get this value is equal to 300, right? So now I am substituting 34A plus B into summation x square. Summation x square is, we get 300. So 300 into B is equal to summation xi into Vi. So that value 94.1428. Let it be. This is equation 6. So now you are solving equation 5 and 6. We get two unknowns, capital A and small b values, right? Solving equation 5 and 6, we get, so for solving these two equations, again we are using the calculator. So in your calculator, mode can be changed to equation. So press mode 3 times and equation 1. Here we are having two unknowns. Press 2. Give the values A1, B1, C1. A1 means capital A quotient, B1 means B quotient, C1 means constant value. 5 equal to 34 equal to 13.2479 equal to, next A2, 34 equal to 300 equal to 94.1428. Press equal to, we get A value is equal to, capital A is equal to 2.2485. And again press equal to, we get B is equal to 0.0589. So after getting capital A and B, here we want small a and small b. But we have here capital A, since we know that capital A is equal to log small a base e. This implies small a can be written as antilog of capital A or e power capital A. So this implies small a is equal to, using calculator we are finding small a, that means e power, I am giving a value 2.2485, that is equal to 9.4725. So now I am getting all two values A and B. Substituting AB values in equation 1, we get exponential curve. Therefore, y equal to A value is 9.4725 into e to the power of B value is 0.0589 into x. So, which is known as a required exponential curve for the given data. Next problem. Fit y equal to AB power x. AB power x is also an exponential curve by the method of least squares to the following data. And they are given x values are 0, 1, 2, 3 up to so on 7 and y values are 10, 21, 31, 59, 92, 200, 400 and 610. So for the given data we have to fit a exponential curve. Here exponential curve in terms of y equal to AB power x, right? So first I am writing y is equal to AB power x, they are given. Let it be, this is equation 1. So for solving this equation, here we are using the least squares method. So before going to the least square, first of all this equation we are changing into straight line equation. For changing straight line equation, this can be for changing straight line equation, we are taking for equation 1 log base e on both sides. Already this derivation we done previously. So log base e, if you are taking, we get log y base e equal to log a base e plus x into log b base e we are getting. Okay, and this is also can be written as capital V is equal to A plus capital B into small x. So now we are changing equation 1 in terms of straight line equation. Okay, so where capital V is equal to, we are taking log y base e and capital A is equal to log A base e and capital B is equal to log B base e, right? So now for this straight line, let it be, this is equation 2. For solving this straight line, we get capital A and capital B values. Using that capital A and capital B, we can find small a and small b. That values we are substituting in equation 1. We get a given power curve for the given data. Okay. So for this equation 2, we have to write down normal equation by using method of least squares method. So the first normal equation is summation Vi equal to Na plus b into summation xi. Let it be, this is equation 3. And summation xi into Vi equal to a summation xi plus b summation xi square. Let it be, this is equation 4. So we are solving these two equations. We get capital A and capital B. Using that capital A and capital B, directly we can find a small a and small b. So for solving these two equations, we want here summation Vi, summation xi into Vi, summation xi square values. For these values, we are constructing a table. So for this, x values, y values, and x values are there given 0, 1, 2, 3, 4, 5, 6 and 7. And y values are 10, 21, 31, 59, 92, 200, 400, 610, right? See here, summation xi we want, that means adding all these values we get summation xi. So which is known as 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 equal to summation xi is we get 28. Next we want summation Vi, but V means log y base e. That means take the log base e for y values. So here I am writing V equal to log y base e. So log y base e we are taking, that means in your calculator use ln. So I am finding ln 10, that value equal to 2.3025. Next ln 21, that is 3.0445, ln 31 3.4339, ln 59 that is 4.0775, ln 92 4.5217, ln 200 5.2983, ln 400 5.9914, ln 610, that value is equal to 6.4134. So here we want summation Vi, that means we are adding all these values, we get summation Vi. We are adding all these values, we get 35.0832. Next we want summation Xi into Vi. So that means we are multiplying X into V. So X into V, 0 into this one is 0, 1 into this one is 3.0445, 2 into this one. So 2 into 3.4339 equal to 6.8678. 3 into 4.0775, 12.2325, 4.5217 into 4, 18.0868. We are multiplying X into V. Next, 5 into 5.2983, that value 26.4915. Next, 6 into 5.9914, 35.9484. 7 into 6.4134, that is 44.8938. So these are the values for X into V. Here we want summation Xi into Vi. That means we are summing all these values. We get that value 147.5663. Next we want summation Xi square. That means X values we are doing squares. So X square, 0 square, 0, 1 square, 1, 2 square, 4, 3 square, 9, 4 square, 16, 5 square, 25, 6 square, 36, 7 square, 49. We are summing all these values, we get that value is equal to 140. So now we get all the summation values. So these summation values we are substituting in equation 3 and equation 4. Equation 3 implies NA plus, where N is equal to number of observations 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 8 observations we are having. 8A plus B summation X. Summation X is 28. So 28B is equal to summation V. 28B equal to summation V, that is 35.0832. Let it be, this is equation 5. Next for second, equation 4 implies A into summation X. Summation X is 28A plus B summation X square. X square is 140B is equal to summation Xi into Vi, 147.5663. Let it be equation 6. So now we are solving these two equations. We get capital A and capital B value. For solving these equations, again we are using calculators. Now our calculators we are changing the mode into equation mode. So press mode 2 times, we get equation 1, and here we want two unknowns ABs we want to find out. So press 2 and give the values of A1, B1, C1, A2, B2, C2. A1 means A quotient, 8 equal to 28 equal to 35.08 2.32 equal to, A2 means second equation AB and constant, and that is 28 equal to 140 equal to 147.5663 press equal to, we get capital A is equal to 2.3208 and capital B is equal to, again press equal to, we get B 0.5898, but here we want small a small b, so therefore small a equal to anti-log of capital A. This is also can be written as e power capital A. So that is e power 2.3208. So that is 10.1838. Next, small b is equal to anti-log of capital B, that is e power capital B is equal to e power 0.5898. Using your calculator, we are finding this one, e power 0.5898, we get that value 1.8036. So we get small a small b. The small a small b values are we are substituting in equation 1. So therefore we get capital Y equal to AB power x. A is 10.1838, B power x 1.8036 whole power x. So this is the given exponential curve. We are fitting the given data for the given exponential curve.